So first thing we want to do is parse out opcode and arguments from our instructions, which we've already read out of the file. So the instruction format, there's 3 instruction formats in Lua, ABC, ABX, and ASBX. Every Lua instruction has an A field. The first format has a C field and a B field also. The second format has BX, which is just combining B and C. The third format has SBX, which is just BX but interpreted as a signed integer. I don't think it's 2's complement. I think it's whatever the other one is, where it just has a bias. So maybe we should add a new Lua type that's like a Lua instruction, right? So let's call it class Lua instruction. So A is really, it's a byte, but does it make sense to index with that? Probably. Let's just do that like exactly how it is in the spec right now. C and B are longer. Maybe we should make them all the same size. Like maybe they should all be 32-bit just for ease of doing math. And then BX and SBX can also be 32-bit. I32, right? Yeah. Okay. And with that out of the way, we can start parsing the instructions. Let's make a new function. That's let's put it up here. Load Lua instruction. Take the buffer. Actually, I don't think we need the header. And it'll return. All right, we have to include the Lua instruction type. This will return a Lua instruction. And first thing we want to load, oh right, I forgot the most important part, which is the opcode. This can be a U8, I think. I think probably the best way to do this is to just read in 32 bits and then just use a bit mask to get the important parts out. So we'll go into buffer reader and we'll add a function that just reads in a 32-bit number. Probably could load the buffer just one time, then pass around either reference for the buffer or even array slices of the buffer. Otherwise it will copy the buffer. Are you sure it's copying the buffer? If it's an object? If I pass an object to a function, does it not automatically pass it by like a reference? I feel like it is by reference because what I'm doing here, like for instance, when I'm in load Lua chunk, I'm doing stuff like buffer.next integer of size, which is going into buffer reader, and then this function is calling next byte, which is incrementing the index, and that change stays. That change stays, so when I move to the next instruction, I'm at the correct index. So I think objects are being passed by reference. So running with that assumption, what was I doing? Right, next U32. Correct me if I'm wrong, anyone who happens to know better. So like, let byte 1 equals next byte, dot next byte, I mean. Why don't I just do that? 3, 4, and then we can return. Oh, right, we have to typecast these. Okay, get it together, man. Byte 1 or width byte 2, shift it to the left by 8. Uh, 16. Uh, 24. That should do it, I think. So on buffer, we will call, we'll say let raw instruction is buffer next U32. And now we can parse out stuff. So we'll say let A be a U32, which is raw instruction and the first 6 bits. And then C U32 is raw instruction and let's right shift it by 6. Oh wait, what am I doing? This is binary, so I need, is it 0B? Oh, this is easy. That's just 0xf. Parse out the B field, right shift by 14. And this is like 0x1f. Okay, well now that we have these, this is should be really easy. Because BX is another U32, which is C ORed with B left shifted by a 9. Okay, SBX is just BX, but we like subtract a bias. Is it 131071 or something? So if we have -1, then it will be encoded as, yeah, okay, this is correct, I think. Does this subtraction even work? Does this make any sense? Because this is unsigned. It should work. Let's just find out. Instruction. Opcode. I forgot the, yeah, duh. I parsed out the opcode as A. So let opcode, this one is raw instruction. Bit mask that. C is, you have to bit shift it by 14, and then B is like 23. Take opcode. I swear. There we go. Good. Good, I think that works. So now let's use it. Let's change our instruction list to take, instead of U32s, we want Lu instructions. And here we want Lu instructions. Here we want to push load Lu instruction. Let's print out some opcodes and make sure we're doing this right. Let's print out the whole instruction actually. Print ln. This syntax highlighting does not look right. There's something going wrong around here where the syntax highlighting just starts breaking, because look at SBX. It's the wrong color. But it seems to figure itself out when we reach the end of the scope here. So opcode A, C, oops, B, BX, SBX. We'll do it in this order actually. Okay, shall we see if this works? Okay, so that subtraction does not work. This should be like, wait, what's the right way to do this? Because a U32 can contain a more positive number than an I32 can. So we can't just cast it to an I32 and then subtract the bias. That just doesn't make sense. Actually, because BX is only ever 18 bits wide, it can never use the full positive range of a 32-bit integer. So I think it's actually fine to cast it to an i32. Let's just see if that causes the same failure. Okay, that's a good sign. Yeah, okay, so this is exactly what I would hope would happen. Okay, this is good. So we have one, which is load k. We have get global, load k, call, get global. So load k has opcode of 1. Get global has opcode of 5. So if we scroll up and look at our output up here, we get 1 and 5. That's good. Then we get 1 again. So it should be another load k. Yep. Call, which is 28. 28. That's good. 5, so another load k. Cool. Move, which is 0. So we should see 0, 28, 30. 0, 28, 30. 0, 28, 30. So we're parsing opcodes correctly. Let's make sure that A, B, and C are correct. So this makes sense, right? Because we're loading the first constant into the first local slot. So these should all be 0. Here, though, that's a get global. Let's see what Lewis C says. 1 minus 2. I'm not sure what that's supposed to represent, to be honest. Oh, Lewis C has like its own weird way of printing out debug information where the numbers don't actually line up with what the opcode actually, or what the instruction actually has. It has its own like notation. Indexing the constant list, it puts a negative in front of that. One good way to check would actually just be to do this kind of thing, where we index the constant list and see if they're accessing the correct constants. Let's comment this out. Syntax highlighting, still trying its best. So once we're done parsing, I'm gonna actually go through the instruction list and print out some information. 402 size code, or right, to give it a variable. Can I do this? Oh wait, no, this is probably good to know. We'll print ln instruction, the opcode, all the things, and then we'll say print. If the instruction opcode is 5, which is get global, we'll print we need the Lua constant that is oh wait, no, we don't want get global, we want load k. Sorry, I'm like confusing myself here. Load constant blank to slot blank. We want to say constant list at instruction bx, and then the slot is instruction A. Let's try that. Interesting. It looks like it's trying to be an out of bounds error. Instruction list is supposed to be size code elements long. Yeah, I thought that. I thought it might be size code -1, but we're starting at 0. So like I should get something, right? Like I should see some output. Like this would run until it got to the end of the instruction list, and then it would give me the error, right? You're probably right. I was wondering, like, 1, 2, 3, 4, 5, 6, 7. A, B, C, B, X, S, B, X. What am I missing? Oh, the, yeah, instruction position. I was wondering why I just pointed at my screen. I was wondering why this, maybe that's what's causing that weird syntax highlighting? Or maybe it's just the, no, it's just like that. Okay. Good catch. Format strings. I don't know why I struggle with that. I could stare at this code for hours and never spot the format string issue. Yeah, there we go. You're a genius. Now this is weird. Oh, that's why. Because it's over here. This else is stupid. Let's do that again. Just so it's cleaner. Load 3.14 to slot 0. Load hello friends to slot 2. Load this is another test print to slot 2. Now let's check again what the Lewis C output said. 3.14. Hello friends. This is another test print. So this is good. We're matching the... I think we're parsing this correctly. Very nice. Thank you, Matco. Let's just comment out this debug printing. Maybe I changed the music we're listening to. All right. So now maybe we can try executing some instructions. Wouldn't that be cool? Maybe we'll do this in a big function. A gigantic match statement. Wouldn't that be grody? Yeah, let's just say run instruction. We need some kind of state. We need like a Lewis state. We'll get back to this. Right. So what does a Lewis state have? It has like, we'll have it contain the prototype. We'll have it contain the registers. Well, actually each function gets its own state. So maybe this is better called like a scope. Let's just call it a scope. Yeah. And then it has a list of registers, which are just constants. So, but maybe it makes more sense to, I don't know, we'll just do a list of Lua constants for now. I think that's all the state needs right now. Maybe we need a constructor. How do constructors work? Maybe I should copy the arguments over to the registers, or should I just set the registers equal to the arguments? Like that? It feels weird having a constructor that can throw. We'll do for argument index in 0 to arguments size, registers push arguments argument index. So yeah, I think it's okay to use Lua constants like this in this context because, well, I guess in some implementations of Lua you can have registers be mutable. So like the values that are in registers, you can directly manipulate them, like add and subtract. But I think in this VM, I'm just going to have it for now, at least, so that when you do any math or anything, it just it takes the values out, it computes the answer, and then it creates a new Lua constant and just puts it in the slot. I still don't know if I'm doing constructors right. Like, does this make any sense at all? Does it need to return a Lua scope? Like, they have this whole section on structs and classes, but there's no example of creating a constructor. Should I make like executing the instructions part of the Lua scope? Maybe that would be kind of cool. Maybe we should pass this function the index. What am I doing wrong here? Oh yeah. Once again, this syntax highlighting is bugging out on me a little bit. Okay, so let's handle instructions like this. Let's match on the opcode. Or let's get the instruction first of all. Dot prototype dot instruction list index at instruction index, and then we'll match on the instruction dot opcode. Yeah, this is fine. Okay, so now we can start implementing opcodes. Let me look back at the reference. 0 is move. That's an easy one. Maybe I should just look up Lua opcode table or something. Register B gets moved into register A. So we'll say registers instruction A instruction B. Sure. One we know is load constant. So I think that's registers instruction A is registers, or no, not registers. It's a prototype constant list instruction BX. Yeah. Okay, I'm going to pull up a table because reference document is actually not very good at showing this stuff. Opcodes.h, that's a good thing to look at, I think. Yeah, they have a great table in this header file. It's actually kind of incredible to look at. Let me check this out. It's all part of the enum, but then they like turn it into a table. It's kind of fun. Load boolean is the opcode number 2. That is registers instruction A is boolean B. Oh, we want to do something like instruction B. Oh, we need to create a new Lua constant for this. So do like maybe we need to keep track of a program counter in here, because the load bool instruction can actually modify the PC. So we have to say if C PC++. Oh, well, yeah. Do I have to do that? That seems a little clunky. I do have to do that. Yeah, can't inline it. Does it allow me to do it like next line? No. That's fine. Number 3 is load nil, which will set registers A through B to nil. Or no, instruction A, instruction B, register index equals Lua constant nil. Maybe I should comment what these instructions are. This is move. This is load K. This is load bool. This is load nil. We have get up value. I don't think I want to implement that right now. Because that's a little complex. I think we need to know about our parent scope to use get up value, because up value is like I'm having trouble speaking. An up value is a local variable that was declared in a scope above the current scope, any scope. So like it doesn't have to be just the parent scope, it could be the one above that. We want get global. So we actually here we need to know about some kind of global state. Maybe we do need like a Lua environment or something. Yeah. And then here we can just do dot environment, like get global, and then the name of the global, which is a constant indexed by bx. So prototype constant list instruction bx. And this doesn't exist, obviously, but the function this. It'll return a Lua constant. I'm gonna have to stop using Lua constants for the registers, because I just remembered that registers can contain like function references and tables, which are not representable using the Lua constant class. But for now, we'll return nil. We save that to registers A. Get global needs, of course, a Lua constant. Let's separate these out maybe. Oh my lord. Dude, this is like painful to look at. Where's the immutable variable assignment? Like I assigned to, oh wait. Okay, that's a weird error to get for putting a dot by accident. Well, we figured it out. So setup val, another to do. Set table, another one I think we can't do. Why don't I implement the stuff that's in this file so we can stay on track and get something working. So we have 1 and 5. We need 28 and 30. 28 is call. So these are kind of complicated. And I can't even implement them because I'm still using constants for my registers. Maybe it's time to stop doing that and be smart. I haven't eaten my sandwich. It's cold now. I'll tell you guys what, I need to eat lunch, so I'll put a pause on the stream. Maybe during the pause I'll have lunch and I'll try to swap out, because this is going to be boring, creating a new type to replace Lua constant for registers. I'll do that maybe during the break, and then I'll start up again when I have something to show and when I'm fed. And we'll see you guys maybe in like a half hour or something.